I don't know anyone in an enterprise that says, boy, you know what we really need to do, like to solve problems in our business? We need to go buy a stack of 300 new switches. We need 3,000 GPUs, a bunch of cables and cooling. What enterprises want to buy is solutions to problems. It's going to be interesting to see how these organizations work with an ecosystem of providers, channel partners, organizations that are going to take these Lego blocks and put them in together in a way that when they're all done, the customer gets the fancy Millennium Falcon.
Welcome to the podcast dedicated to the art and science of observability. This is Signal Over Noise. Welcome to another episode of Signal Over Noise. I'm your host, Sara, and today I have Rob Cowart, co-founder of ElastiFlow, and Madison Grubb, senior SRE at ElastiFlow. So before we get into it, Super Bowl, did you guys watch?
Well, I watched the highlights because, I live over in Germany, and I wasn't going to stay up to like 3 a.m. or whatever to see the game live. And as it turns out, I'm more of a offensive-oriented fan. So being the defensive battle that it was, I can respect, but I actually was kind of like, boy, I'm glad I didn't stay up to watch this game. But Sara, I have to ask you some questions, okay? So, the Super Bowl is about more than the game, right? There's the halftime show, and then there are the commercials.
The commercials,
and so,
my Super Bowl, the Super Bowl.
Yeah. So, you being from the ElastiFlow marketing team, I would love to hear some of your feedback on the commercials.
Oh, man. Well, 30-second commercial is costing them anywhere between $8 and $10 million. So my big question is that really what these marketers want the takeaway to be? Is that we had an AI-generated commercial? I think we really need to stop and ask, just because you can do something doesn't mean you should, which brings me to the commercial with, I think it was Xfinity and Jurassic Park and the slopification, the de-aging to Svedka Vodka's Fembot that they brought back and their new Brobot. And I mean, just some curious choices were made. What about you guys? What do you think about the AI usage?
I thought the Anthropic ones were kind of funny. I thought the vodka robots were silly. I still kind of wonder what Agent AI does, but I heard they paid about $70 million for their domain and then about $8 million for the Super Bowl commercial, and they're out of VC funding.
And I heard the website crashed too, so people watched the commercial, still didn't know what it was.
Wow, okay.
Went to the website and
got nothing.
An error there.
So basically, they'd probably say it worked, and then it crashed. So
sort of, yeah.
But yeah, I actually thought because look, the Super Bowl is going to be all about consumers, more so than like business to business type things. But I actually did think the Google commercial was probably good, where they had the kid was trying to imagine the new home he was going to move to and stuff. And his mom used AI to help him see his new bedroom and see his new garden. And I felt it was the one that was probably the most grounded. Maybe it's the best word. Yeah.
I like that.
Yeah, there seems to be that dichotomy where you've got the AI slopification where people are kind of just throwing as much as they can, but then you have the other side of people using it to tweak their existing workflow to, make something that's wholesome and useful and actually hits home. So I think there's a good mix there where you're seeing, well, I don't know if it's a good mix, but there's a mix there where you see the positives of it versus the negatives of using the same technology.
So both sides of the coin, so to say.
Yeah, exactly.
Definitely. Well, speaking of AI, we are at Cisco Live Amsterdam this week, Cisco Live EMEA, and AI has been a big theme of that event. Rob, any key takeaways?
Yeah, there were a few announcements that I thought were interesting. They did announce Silicon One with a new chip or, new foundation for a switch called G300. Apparently this is going to be in some of the new Nexus 9000 series, as well as some other platforms as they go. They had some interesting claims about that as well. They talk about one metric of job completion time. Let me look to make sure I don't say it wrong. 28% improvement in basically the time it takes for jobs to finish, which is, not a bad way to think about performance of an AI cluster. At the end of the day, whether it's training things where you want it to finish training as quickly as possible so you could evaluate those models, move into production. You also have from a user experience, like in inference workloads, more quickly things can do their job, the more quickly you get answers back. I think to understand the supposed advantages, you need to understand a little bit about networking within an AI or a GPU cluster, if you will, and why that's a bit different.
What is that? How do I hear a lot of people talking about like RDMA and XO and things like that? When we get to the network side,
the important part is the RDMA, right? The memory transfers from one GPU to the other. And so if we think about that, what makes the workload so different in an AI standpoint is, let's say, and we're going to talk about a 64 port switch as an example. That's what they kind of give in their example. In a typical workload, let's say I, just plugged in 64 servers into a switch. Well, the reality of it is maybe some of those servers have some requests at the moment. Maybe they don't. The workload, sometimes one server's busy, sometimes the other's busy. But it's a very rare occasion that all of the ports are fully loaded all at the same time. Just doesn't happen very often. What you tend to see is a little more sporadic. And even if you have sustained usage of the network, it's rarely going to be like 100% sustained usage. AI networking is completely different. So let's say we're training a model, right? Each GPU gets given the amount of data loaded into its VRAM that is relevant to what it needs to calculate in a given cycle. Data gets loaded up, the GPU does its work. While the GPUs are working, nothing is working. Like there's almost zero
network traffic.
Right?
Yeah.
And then the GPUs get done and everyone's like, okay, now transfer to the other GPU all the parts it needs. And so then see all the ports go up to 100%. And basically that whole transfer, because the next stage can't start until the slowest transfer is ended, then all the transfers happen, boom, the network goes back down to zero while all the compute's happening. So while you don't have sustained load of traffic, when you have traffic, you're using all the ports at their full capacity. So it's really important that the switching fabric is able to truly handle full load on all of the ports. And of course, you want those transfers to happen as fast as possible, so you want to have a lot of bandwidth. The other part of this, though, that becomes the more challenging part then is, how do we handle things like congestion? So when you're doing RDMA over Ethernet, you're going to use something. There used to be a Rocky V1 RDMA over converged Ethernet, which actually worked more as a layer 2. So you were limited really to like one broadcast domain because it wasn't using IP, a layer 3 protocol on top. Yeah, exactly. No IP. And so Rocky V2 encapsulates the RDMA traffic. I mean, it literally is like an InfiniBand type payload, encapsulates that inside of UDP packets. What happens though is the switch is trying to pick the ports to send the traffic across. It has to, and I should note, this is generally not a problem if it's just a small number of GPUs all into one switch. But when you have multi-tiered switches, I mean, think about some of the numbers that like Amazon and Meta and Google and everyone, the number of GPUs they're buying, right? You can't do this with a single layer of switching. You have multiple layers of switching. And as you move across these aggregation switches, they need to know which links to send across to make sure that things don't collide, so you don't have congestion. Because what happens if the switch ever basically has to give up, in other words, its buffers fill up, then basically the protocol has to say, at the IP level, send a congestion notification, hold off. Well, what happens? Boom, cuts bandwidth in half. So that fancy 1.6 terabit per second switch is now 800. Another congestion of 400. And so all of those transfers start to take longer because even if it happens to one, we're waiting on the slowest to finish. Exactly. Yep. One of the ways that this can be handled is just buffering. There's a congestion, you need to buffer packets temporarily, et cetera. So, and that's one of the things they talk about is they talk about this unified buffer. I guess the best way to think about that for anyone listening that knows about CPUs, right? In AMD's CPUs, you have the chiplet design, and each of the sets of cores in each chiplet has its own layer 3 cache in it. But that only is layer 3 cache for the cores in that chiplet. When that cache is full on the chiplet, those cores don't get any more. It's kind of the same a lot of times in switches, is you'll have chunks of buffer. And if your particular port, its buffer doesn't have anything available, well, then you can't put anything in the buffer. You have congestion and the negative effects we talked about. They talk about a unified buffer. In other words, every port has access to the buffer. So if there's any space available in the buffer, any port can use it.
Any port. Oh,
Yeah,
okay. That's cool.
So that is advantageous for sure. And I would say is a good aspect of it. Now, I do question though whether that really accounts for the whole 28% performance improvement. From what I could gather, most of those performance comparisons were done with Ethernet switches just doing like normal congestion control. And normal congestion control is basically going to be just on a given port on a switch with no knowledge of downstream switches. However, that's a little bit unfair because the silicon one, the G300 probably compares most closely to like the Broadcom Tomahawk 6 chipset, which is in some switches from Juniper's QFX series to like 7,000, 7,800, something like that. It doesn't just have the load balancing or congestion control with load balancing on the switch. It has a global load balancing function so that any given switch can make decisions on information from other switches. And that way it can make an end-to-end routing decision or forwarding decision in that case, not just a switch-centric forwarding decision that could cause collisions. I'm kind of curious about, in the keynote, they talked about it being the most programmable switching silicon, or switching fabric, but didn't really go a lot into about what that
What that means.
Yeah, exactly. What does that programmability mean, and what type of things could be done with it? I'm gonna be curious to see where that goes.
We love those breadcrumbs they leave for us.
That's what you're supposed to do, right? I was about to say you're supposed to Google. No, you're supposed to go and search AI for it. This next one, I didn't hear a lot of chatter about, but when I was looking, I thought, wow, that actually looks kind of interesting. And I think it fits some of the observations that we at ElastiFlow are making. They announced something called Cisco Unified Edge. And so what is Cisco Unified Edge? Well, let's think about, I'm going to say, think about the edge of the network. Okay, I get it. Edge is an overloaded term, right? It could be all the way to the edge of the data center to, network gear running in one of those metal boxes on a corner on the side of the road, right? Like just exactly what edge means is a good question. In a couple of their slides, they talked about on-premise edge. So in other words, pushing out into the enterprise. But what they're really talking about is if you need to take a stack of functionality, of network functionality, even compute functionality, and deploy it anywhere, what does that look like, right? Well, I need a router because I got to be able to route traffic to that place. I need a switch. So now we got another unit in our rack. I need a server. What if we have a need to do maybe some edge AI analytics? We need some GPUs out there, and maybe there's folks that need to connect to that wirelessly. I need some Wi-Fi in there. Next thing you know, I've got 8, 9, 10 unit rack that now needs to be deployed and with power requirements, with et cetera. So the Cisco Unified Edge kind of says, let's take all of these things and put them as modules in one single smaller chassis.
One single stack. Yeah.
Yeah. And I think that's kind of interesting. I mean, one of the, we have a customer that I remember in the conversations we first had with them, that we're talking about over 10,000 locations, retail type of organization. And they had multiple things inside the stores. But 2, they wanted to do more in the stores, but they had a need to get compute into the stores. Now, they already had Meraki switching, happened to be a Cisco customer, already had Meraki switches, had other Meraki infrastructure. But where are we going to put compute? In what form factor? How are we going to get all the other pieces and parts? Well, it looks like with Cisco Unified Edge, they could have actually just put a Cisco Unified Edge in each store. I read something that's probably a couple of years ago now. Every Chick-fil-A location, they have a Kubernetes cluster. It literally runs on 3 little Intel NUCs.
Intel NUCs. Yep.
Yeah. And for
Keeps
home
the
lab.
heating pads running and make sure everything is flowing through. Yeah.
I mean, it reminded me of home lab type environment,
Oh
but
yeah. I think there's
the
a big deal there because one of the, especially when you're looking at like managed service providers or smaller level, your doctor's offices,
right.
lawyers, facilities, things like that. I mean, they need a network too, just like anyone else, and it's super daunting to have to figure out every single piece of hardware that you need just to set it up. And a lot of times they go to a managed service provider or try and find someone that tries to piecemeal it all together. And I think it's very obvious, like Cisco's saying, with this unified edge product, to just here's everything all in one spot. It's all, a la
Mhm.
carte. You pick the pieces and you don't have to think deeply about this specific module and where you're going to find it from and how are you going to source it and how are you going to buy it. It comes kind of a one-stop shop. And you even see that with home labs nowadays. A lot of people are kind of becoming ubiquity people or microtech, and they just build out their stack that's just one specific product. So I think this is a wise choice. It's opening up the market for Cisco to kind of be the choice for those smaller groups without them having to put so much effort and thought into what's their local stack going to look like.
Let me just share a stat that they shared because it's relevant. They talked about AI workloads moving to the edge. They said in 2021, 90% of these workloads were running in the data center, 10% out somewhere distributed in the environment. As they say, on-premise edge is the number. Their prediction is by 2027, so like literally next year, they expect 75% of AI workloads will be running in the on-premise edge and only 25% in the data center. Now, I can think of one advantage that immediately popped into my head. You bring the analytics closer to the source of the data. So there's less data you have to transfer. We have some interesting thoughts on that ourselves about observability data. But the other side I wondered about is I'm now distributing my compute, which also, because you can put GPUs in these things apparently. And I'm also distributing my access to power, which sometimes is one of the bigger problems. Like it's great to say we put this big rack of, H200s or something in the data center, but you also got to power those.
Oh yeah,
And
and
sometimes
keep it
that's a
cool.
yeah, yeah. And so you're also kind of distributing some of the infrastructure load at the same time. So where it can just make sense because of the nature of an organization or a business, I think there can be some other benefits that they didn't necessarily highlight either.
If we look at the AI world and kind of where the landscape is going, obviously the frontier models are the best in the class, and you can only get those in the cloud. But there are a lot of very powerful open models nowadays that are open weight, and you can run, through Llama CPP or OLLAMA or something like that, which is really enabling a lot of this stuff to work, on an on-prem solution. So now you're not sending this data out to a third party, so you can do more secure things. Obviously there's a lot of terms of conditions and rules and things like that. But even then, you have that complete authority and ability to know that your information isn't going out into the cloud. I see that becoming more and more popular, especially when it comes to, automating workloads that are like very specific. If you have, a very predefined thing that you need your AI workload to do, and you've trained your model or you have a good model that can handle it, why not run it on the edge? Especially if you have that, compute capability now on premises, then you're not really having to rely. It gives you that kind of data sovereignty as well.
It's great you bring up the local models. I know we do hot takes at the end here, but I'm gonna do an early hot take on
Wild
this
hot
one,
take.
which is, in my opinion, the models we have already are for most use cases good enough.
Good enough. Yeah, I agree.
And I'm not even talking about like the Kimi K2 trillion parameter things. I think like a 30 billion parameter Nematron 3 Nano, or even for some things, we've done some stuff with even like GPT OSS 20 billion parameter. If you feed it the right context, so the right information, the right data for a specific task, a lot of them
It's
are,
perfectly fine. Yeah.
plenty good enough. Anyway, that's probably a whole other podcast we can do sometime later. But yeah,
Absolutely.
so. Speaking of stuff we've been doing internally, kind of, y'all been more involved in this than I have actually. So maybe I should let Sara, what happened here this week?
That's right. Thanks for teaming me up there, Rob. So this week here at ElastiFlow, we had a very exciting announcement, the GA of Merman. And Madison, I think you're the perfect one to speak to this. You worked really closely with the team on this project. Can you give us a quick rundown of what Merman is doing?
Yeah. So, of course, I'm a DevOps engineer. So I obviously want to do DevOps things. I want to handle observability. I want to have that visibility into my network. But I feel like that's been one of the missing pillars for a lot of observability is there's so many solutions out there like Prometheus and Grafana and things that give you metrics, things that give you logging, with Loki, Victoria logs, things like that. We have app traces, distributed app traces. But then when we get to the network world, it's like, here's bytes in and here's some bytes out. Good luck. It's like, well, okay, I don't actually know what's going on with my network. And we've seen a kind of a big push recently to start using eBPF to get some actual relevant, useful packet information. So now with Merman, that's what it's doing. It's an eBPF agent. It gives us that packet capture capability. And the observability tools that we already use. I was talking to Rob about this earlier, but our biggest beta user has been ourselves. So we've been trying this out because we want to have that visibility. We want to be able to see what's going on in our Kubernetes networks, just like we would in our old traditional flow logging. Now I can see all of my flows, but I can also see that Kubernetes attribution. I can see, what pod is talking to which pods, what's going on with the service. Is it reaching out to an ingress? Is it messing around with the gateway? What's the network policy? I get all of that attribution now, just like I would with a regular trace. It really opens the door to basically have all of your pillars in the observability stack. Like I was saying before, you've got your metrics, you've got your logs, you've got your app traces, and now you've got net traces. It just seems like the perfect fit, right? Now you've got the full view. You see everything. You've got CPU, memory, storage, and network all in one place.
And I think an important note on this too, it's open source. So going back to our roots, if you listen to our last podcast, we talk about the history of ElastiFlow coming out of the GitHub project. So I think it's very important to to share that too, right? That it's an open source solution. We'll share in the show notes too. So be sure to take a look at those links to that GitHub repo and the docs and things like that. But
yeah, for all really the DevOps engineers, it's a Helm chart. So it's what you're already accustomed to using to deploy your stuff and get things into your cluster. It follows the same paradigms and same tools. So it's easy to, plug in, and it can connect with the ElastiFlow collector, but it can also connect to any OTLP collector as well. So try it out and see what you think.
We want to, make that an official CNCF project. To do so, though, we need 300 GitHub stars. So if you want to help us help you make this always open source, as Sara said, we should have links here in the description for the show. Go and start the repository so we can hit some of those milestones we need to get that project officially recognized and be able to be governed within that ecosystem. So, of course, we'll continue to maintain and do work on that. But that's important. I think the other thing I would call out about Merman, and it relates to a lot of what we've seen in the market, is I'll just say on all of these things, metrics, logs, traces, as Madison mentioned, we think everyone's moving toward open telemetry for these things, and Merman is an OTel native tool. That's why it integrates with traces, as Madison said. And I think that's a big direction you're going to see us going even more and more as well. Probably a whole other podcast, Sara, to talk about open telemetry, that ecosystem.
So we're bringing open telemetry to NetOps, and we're bringing network data to DevOps. We talked last episode again about the need to break down those silos. And this is what I love. It's democratizing that data across all functions because, let's face it, titles, those lines are blurring. So I think being able to have access to that ground truth, that centralized data, is so important. So let's wrap up today's episode with some hot takes. Now, Rob, I know you already gave us a look into one of your hot takes.
Yeah, that was just a mini hot take.
Just a teaser.
Okay. So
I feel like it was a good take, honestly. Plenty of these models are good enough.
I think in a few months, we're going to prove it to everybody. That's what and we'll leave it at there. I'm not saying anything else.
Those breadcrumbs
So
we talked about earlier.
yeah. So I want to go back to Cisco Live and talk a little bit. They had obviously a lot of conversation about AI, some of the different products we talked about. I want to give a quote. I know I'm going to butcher this guy's name probably. Nick Kukarevsky, Kukarevsky, something like that. Apologize for the mispronunciation there. He is the Cisco Silicon One senior vice president and general manager. And he said, we're building networks with hyperscalers, as like in the present, and starting to build with some of the neo clouds now. But really where we see the next wave of AI deployment starting to happen is within the enterprise customer base. When I look at that statement, I think when we look at the hyperscalers, I'm going to kind of count Meta in there, just, even though they're not really a hyperscaler, but, they operate like a hyperscaler, right? You probably can take XAI and put them in that same boat. They're technically not a hyperscaler like a GCP or an Azure or an AWS, but they operate very much like that. And in neo clouds, I think of some of the other companies, people that are building infrastructure up. They're definitely not on the scale of like a GCP, but they are building up AI specific infrastructure and obviously have a need to network all those things. But the difference between those and the enterprise is that the core business of those organizations is to sell infrastructure or to micro lease it, or however you want to call getting a subscription to some service, right? Their whole task, the product is the infrastructure. For an enterprise, I don't know anyone in an enterprise that says, boy, you know what we really need to do, like to really solve problems in our business? We need to go buy a stack of 300 of those new Cisco Nexus switches. We need 3,000 H200 GPUs, a bunch of cables and cooling and all the things you also had mentioned a little bit about, Madison, earlier when we were talking about the unified edge. They're probably saying, we need to figure out how we can improve the output on our assembly line with 10% less product defects. That's what they want to buy. They want to buy outcomes. They don't want to buy technology. So what I think is going to be interesting, and I guess what makes this a hot take, is it's like, great, you want to sell to the enterprise, but you just told me about a technology stack. And I'm not just criticizing, that shouldn't be taken as a criticism of just Cisco, because I think this applies kind of across the board. What enterprises want to buy is solutions to problems. And it's going to be interesting to see, because it will be a necessity, how these organizations begin to work with an ecosystem of other providers, of channel partners, of value adding consulting type organizations that are basically going to take all these Lego blocks and put them in together in a way that when they're all done, the customer gets the fancy Millennium Falcon, So yeah, that's the hot take, is you got to figure out how to quit selling technology and start selling solution to business problems if you want to see uptake on your technology stack in the enterprise.
That Millennium Falcon should be a business expense is what I heard.
There you go.
I think an interesting rebuttal there is that that is kind of part of what the unified stack is trying to do. It looks like kind of, instead of being like, hey, here's all these different tools and here's all these different, here's your new blade for this and here's your blade for this. It's kind of squishing it all and saying, here's your shovel. You want to increase your capability. Here's how you can do it. Here's one unified piece. And I think if they push it and provide that as an avenue, then maybe they can get a little bit more of that enterprise customer base. Because if they don't, then like you're saying, enterprise isn't going to care. They don't care about what specific switch is being used, as long as it works correctly and is resolving the problems that they're having. That's preventing them to get to whatever their actual goal is.
I mean, you do make a good point. Actually, on the unified edge, I did also see that, and they were pretty prominently talking about this ecosystem of ISV software companies that they have already are working with, that have things that, like, you actually had mentioned medical before, Madison, and I recall one of them that they have is kind of like medical focused to run on those type of platforms. But that And that's good, but they need to take unified edge and now replicate that same thing to all the other pieces and parts as well. That's all.
Agreed.
Yeah. So I think that's the next big hurdle, right? I mean, inside of ElastiFlow, I've been saying for a while, I think the future successful AI companies are not going to be the quote unquote AI companies. Don't get me wrong, Google's going to be successful. I'm sure some of the other ones are going to be successful. The Anthropics are going to be successful. The model providers, that's more, I guess, what I'm referring to. But it is not the AI companies that are going to drive the next wave. It is the with AI companies. In other words, I solved this problem for this industry with AI,
And I think that's a great place to leave it for today. Rob and Madison, I want to thank you both so much for joining and for sharing your thoughts both on the announcements at Cisco Live and our announcement the week of Cisco Live.
Great. Thanks. Really appreciated it and look forward to the next one.
All right. Be sure to check out those show notes. We'll link in the description some helpful links that we referenced today in this episode. And we will see everyone next time. Thanks for joining.
Thanks.